Hello there, and welcome to the Sleepy Science Channel. I'm so glad you found your way here tonight. Maybe it's been a long day, or maybe you're someone who likes to drift to sleep with quiet wonder, letting thoughts of distant worlds replace the noise of daily life. There's nothing you need to do now but rest. Let your mind grow still, your breathing slow, and your body light. Because tonight, we're not just closing our eyes. We're wandering through the gentle vastness of galaxies, the quiet, glowing islands of the cosmos. From their ancient beginnings to their swirling shapes, from soft starlit gatherings to deep cosmic shores, we'll explore 100 sleepy facts to help you relax, unwind, and dream of the universe. And if these calm explorations help you rest, consider liking and subscribing. It helps other sleepy travelers find their way here too. Now, close your eyes and let's begin. Fact 1. The first wisps of light. Long before galaxies spun their graceful shapes across the darkness, the universe was a warm, glowing haze. Everything, every star, every world, every future dream was once drifting in a soft, expanding cloud. As the cosmos cooled, that glow faded, leaving behind a gentle darkness filled with quiet possibility. In that stillness, tiny ripples of density formed, like the faintest breath moving across calm water. These ripples were the first hints of structure, the earliest whispers of places where gravity would slowly gather matter together. Though impossibly small, they were the seeds from which galaxies would someday bloom. You can imagine this era as a vast twilight, serene and unhurried. The universe wasn't rushing. It was simply settling into itself. And in that quiet, the first lights of future galaxies waited patiently to be born. Beyond that, another gathering was already beginning to take shape. Fact 2. Clouds that became galaxies. As the universe continued to cool, great clouds of hydrogen and helium drifted through the dark, simple elements, but full of silent promise. Gravity began to tug at them, with a gentle but persistent pull, encouraging them to come together, little by little. Over millions of years, these clouds thickened, forming the earliest patches of cosmic structure. These weren't galaxies yet, just soft concentrations of gas, dim and unformed. But within them, pressure grew, heat stirred, and eventually, in their deepest pockets, the first stars began to flicker alight, tiny sparks glowing in a cold ocean. If you imagine these clouds, think of fog gathering in a valley at dawn, delicate, slow-moving, beautiful in its stillness. From such unhurried beginnings, the galaxy clusters we know today began their gentle ascent into being. And as these clouds thickened, something even more profound began to take shape at their hearts. Fact 3. The quiet gathering of matter. Inside these growing clouds, gravity performed its patient work. It drew gas toward the center, gently compressing it, forming the early scaffolding of what would one day become a galaxy. Small clumps merged with larger ones, each collision soft at cosmic scales, not sudden or violent, but a slow blending of motions. Dark matter, invisible yet abundant, formed the deep gravitational wells that shaped these early structures. Though we cannot see it, it was like an unseen hand, guiding the flow of matter toward the places where galaxies would eventually bloom. Without it, the universe might have remained a scattered mist. Picture it as dust drifting into a bowl, settling naturally into a shared center. Nothing hurried, nothing forced. And from this gentle gathering, the first outlines of galaxies quietly emerged. Beyond this early architecture, new seeds would soon begin to glow. Fact 4. seeds in the dark. As the early universe continued to settle, tiny knots of matter began to stand out against the fading glow of creation. These little knots were the seeds of galaxies, regions just slightly denser than everything around them. Their difference was barely noticeable, yet it was enough for gravity to gain a foothold, tugging more and more material inward over time. In the quiet dark, these seeds grew slowly, drawing in drifting gas and subtle currents of dark matter. Each seed was unique, shaped by its surroundings, its motion, and the delicate dance of forces acting upon it. Some would remain small, becoming dwarf galaxies, while others would swell into giants. You can picture them as tiny dimples in a vast cosmic fabric, soft depressions where starlight would one day gather. And as they deepened, the universe prepared for its first great structures to shine. Beyond these seeds, the cosmos itself was changing temperature, moving toward a gentler phase of creation. Fact 5. The cooling of the early universe. In the beginning, the universe was hot enough to glow, a radiant fog filling every direction. But as it expanded, it cooled steadily, like a kettle taken off the fire and left to sit in the calm of a quiet kitchen. This cooling allowed atoms to form and photons to wander freely for the first time, creating the deep, dark clarity that galaxies needed to take shape. As temperatures fell, gas could finally settle, gathering without being torn apart by heat. Hydrogen, the universe's simplest element, drifted peacefully, ready to collect into clouds. And as these clouds thickened, the first stars waited just beyond the horizon of time. Imagine this cooling as the slow, soothing exhale of the universe, the moment when things became calm enough for structure to appear. And into that coolness, gravity began to weave its gentle music. For it was in this cooler universe that gravity truly began to guide the cosmos. Fact 6. When gravity learned to sing with the universe cooler and its ingredients free to drift, gravity began to shape the cosmic landscape with newfound grace. It moved like a slow, steady melody, gathering gas into denser pockets, stretching dark matter into unseen frameworks, and encouraging small structures to combine into larger ones. This was the era when gravity learned to sing, not with sound, but with motion, pattern, and rhythm. Tiny clouds spiraled toward one another, merging in long, patient embraces. Over millions of years, these motions created harmonic patterns that would become the familiar shapes of galaxies. Think of it as the universe beginning a soft waltz, gentle and unhurried, each step drawing matter closer together. And from this quiet choreography, the first true islands of stars were poised to emerge. Beyond these early harmonies, the first hints of spiral shapes began to drift into being. Fact 7. Islands taking shape. As gravity continued its quiet work, the earliest galaxy fragments slowly grew into recognizable forms. These weren't the elegant spirals or smooth ellipses we see today, but small, lumpy collections of stars and gas, humble beginnings for the grand islands of light that would someday fill the cosmos. Each fragment moved through space with its own gentle momentum, drifting, merging, and reshaping itself across millions of years. Over time, these fragments blended together like soft clouds meeting in a calm sky. Their stars settled into shared orbits, and their gas pooled toward their centers, creating the first hints of structure. In these early gatherings lay the foundation for the galaxies to come. Picture these proto-galaxies as floating lanterns in deep water, faint and unsteady, but full of future brilliance. And as they grew, another transformation began to sweep across the dark. Fact 8. A sea filled with spirals. With more stars forming and more gas settling into smooth motions, the universe slowly filled with swirling shapes. Spirals emerged from the gentle tug of rotation as matter orbited the centers of these young galaxies. Over long stretches of time, the arms began to wind outward like brushstrokes, delicate and glowing with new starlight. These early spirals weren't perfect or symmetrical. They were loose, wandering, and softly textured. But even in their youth, they showed the graceful patterns that would make spiral galaxies some of the most iconic structures in the universe. Each arm carried clusters of stars, pockets of nebulae, and lanes of drifting dust. Imagine these spirals as cosmic pinwheels slowly turning in a vast, silent ocean. Their curves shimmered faintly against the backdrop of the night, and within their swirling embrace, something bright was waiting to be born. Fact 9. The slow birth of starlight. Inside the arms of these young galaxies, clouds of hydrogen and helium began to collapse into dense pockets, the cradles of new stars. Gravity pressed the gas inward, and heat built steadily until the first nuclear fires ignited. Tiny, glowing suns emerged, each one sending its gentle light into the surrounding dark. At first, these stars were scattered and quiet, mere specks in an enormous canvas. But gradually, they multiplied, forming clusters and constellations within their galaxies. Their light softened the darkness, tinting nearby gas with faint warm hues. These early stars helped shape the galactic arms, defining their structure and rhythm. Think of starlight, blooming like fireflies in a summer field, small at first, then growing in number until the night begins to glow. And as these stars illuminated their galaxies, their centers prepared to shine even more brightly. Fact 10. Galactic hearts begin to glow. At the center of each young galaxy, matter drifted inward with quiet determination. Gas, dust, and ancient particles spiraled gently toward the core, gathering in a dense, warm cradle. Over time, this central region became a luminous heart, shining with the combined light of countless stars packed closely together. These stars were older and steadier, forming the first stable anchoring point for their galaxies. In these glowing hearts, the earliest galactic structures found balance. Their surrounding stars orbited in soft, sweeping paths, guided by the calm gravity of the core. The centers shimmered like embers in the fireplace of the cosmos, warm, steady, and comforting. Imagine looking into the heart of a galaxy and seeing a golden cluster, radiant and serene. And as these bright cores strengthened, the arms around them began to form patterns of their own. Fact 11. The swirling arms. As galaxies matured, their central glow helped organize the motions of the stars around them. Rotation gently shaped these motions into spirals, graceful, trailing arms that stretched outward with quiet elegance. Each arm was a river of stars, drifting dust, and softly shining nebulae, all moving together in a slow, harmonious dance. The arms weren't rigid structures, but patterns of motion, like waves forming in water. Stars flowed into them, lingered for a time, and drifted out again, while the spiral pattern persisted. Along these arms, new stars continued to form, adding soft blue highlights to their sweeping curves. Picture these arms unfurling like long ribbons in a breeze, delicate yet enduring. And as some spirals grew more complex, a new feature began to appear across many galaxies. Fact 12. Bars across the sky. In many maturing galaxies, A striking structure formed across the center, a bar of stars stretching from one side to the other. These stellar bars acted like cosmic bridges, guiding gas inward toward the core and helping shape the galaxy's rotation. They were made of old stars, glowing softly, moving together in a slow, stately pattern. Bars played an important role in galactic evolution, stirring the inner regions and creating pathways where new stars could take shape. Their presence often strengthened spiral arms, helping them reach outward more elegantly. Though they seemed solid, they too were patterns of motion, gentle, elongated waves of starlight. Imagine a bar as a quiet beam glowing across the galaxy's heart, steady and serene. And beyond these bars, even more hidden structures lay waiting in the surrounding darkness. Fact 13. The hidden halo. Surrounding every galaxy, like a faint whisper around a song, is a vast and nearly invisible halo. This halo stretches far beyond the bright disk we typically imagine, reaching out into the quiet dark with a gentle, ghostly presence. Made mostly of dark matter, along with scattered stars and ancient clusters, it forms the silent foundation that holds the galaxy together. Though the halo cannot be seen directly, its gravity is unmistakable. It steadies the orbits of stars, shapes the galaxy's rotation, and provides the scaffold upon which the familiar structures rest. Without it, the swirling arms and glowing core would drift apart like dust on a breeze. Imagine this halo as a soft, transparent shell, a protective cocoon around the galaxy's luminous heart. And within this hidden sphere, other, more delicate structures quietly unfold. Fact 14. Rivers of dark matter. Dark matter flows through and around galaxies like quiet, unseen rivers. Though we cannot touch or see it, we feel its presence through the way galaxies move. Its gravity draws stars into stable orbits and forms gentle channels of influence that guide the shape of the entire galaxy. These invisible currents are the reason galaxies hold together with such calm strength. Scientists believe dark matter forms filaments and streams, thin and delicate as spider silk, weaving through the cosmos in intricate patterns. Galaxies form along these silent pathways, settling into the densest regions where dark matter's pull is strongest. Picture these dark matter rivers as soft, shadowy lines beneath the starlight, shaping everything without ever shining themselves. And carried along these currents, the visible parts of galaxies settle into familiar forms. Fact 15. The soft disk of stars. Near the center of many galaxies lies the stellar disk, a thin, graceful structure where most of the stars quietly reside. This disk is like a cosmic meadow, wide and gently glowing, filled with stars that orbit in smooth, nearly circular paths. Over billions of years, these stars have settled into a flat plane, drifting together in serene, aligned motion. Dust and gas weave through the disk in long, delicate lanes, creating nurseries where new stars slowly come to life. Meanwhile, older stars glide peacefully along their well-worn trajectories, contributing to the warm, steady light of the galaxy's body. Imagine the stellar disk as a calm, luminous lake, its stars shimmering like reflections on gently rippling water. And resting above and below this tranquil plain, even older structures wait in silence. Fact 16. Bulges that hold ancient suns. At the heart of many galaxies sits a rounded bulge, a glowing mound of ancient stars gathered close together. These stars are old and steady, their light warm and golden, like embers that have burned quietly for billions of years. While the spiral arms host younger, bluer suns, the bulge preserves the memories of a galaxy's earliest generations. The stars here orbit in many different directions, moving in gentle, looping paths rather than the orderly circles of the disk. This creates a softly shimmering glow, dense and serene, shaping the core of the galaxy like a calm, luminous hearth. Imagine this bulge as a lantern of old light, suspended at the galaxy's center, glowing with deep, steady radiance. And surrounding this heart, the galaxy stretches outward into quieter and more delicate regions. Fact 17. The faintest outskirts. Far beyond the bright spiral arms and the warm central bulge lie the outskirts of the galaxy, remote, dim regions where only a few stars drift. These outer reaches are so sparse that from afar, they seem almost invisible, like the edges of a watercolor fading into the paper. Yet they hold a special quiet beauty, a soft boundary where the galaxy gently blends into the surrounding night. Stars out here move slowly, influenced both by the galaxy's gravity and the embrace of the dark matter halo. Many of these stars are ancient travelers, remnants of long-ago mergers or faint memories of dissolved star clusters. Their light is subtle, barely brushing the darkness. Picture walking to the edge of a glowing city at night, where the lights thin, the air grows still, and space opens wide around you. From this peaceful frontier, a delicate web of gas stretches even farther outward. Fact 18. A gossamer web of gas. Surrounding galaxies is an extended halo of gas, thin, diffuse, and almost impossibly faint. This gas is like a gossamer veil, stretching far beyond the visible stars. It consists of hydrogen, helium, and trace elements from past generations of stars, blending quietly with the cosmic background. Though nearly invisible, it plays a vital role in galactic life, offering material for future star formation. This diffuse gas moves in gentle currents, warmed by starlight, supernova remnants, and the slow stirring of gravity. Over millions of years, parts of it drift inward to replenish the galaxy's inner regions, while other parts float freely, waiting for subtle changes to guide them. Imagine this gas as a soft mist illuminated only by memory, delicate, flowing, and serene. And within this mist, smaller communities of stars begin to gather and take shape. Fact 19. Clusters. Within galaxies, scattered throughout a galaxy's disk and halo, are clusters of stars, quiet gatherings formed from shared beginnings. Some are small, loose associations of young stars, glowing with blue-white light. Others are older, tightly bound spheres called globular clusters, their stars packed together like grains of warm sand. Each cluster holds a story of stars born in the same cloud, drifting through the galaxy side by side. These clusters move along gentle orbits, circling the galaxy's center over vast stretches of time. Their paths can carry them through spiral arms, into the halo, or along ancient trails left by past mergers. Even as individual stars wander, the cluster as a whole maintains a soft, cohesive glow. Imagine these clusters as cozy neighborhoods nestled within the great galactic city, each with its own history and personality. And as we look outward from these communities, we find even stranger suburbs of stars. Fact 20. The secret suburbs of stars. Beyond the main disk of a galaxy, faint collections of stars drift in loosely held patterns. These are the galaxy's suburbs, diffuse stellar regions that formed from tidal interactions, mergers, and long-past collisions. The stars here often carry hints of other galaxies, remnants of ancient interactions preserved like gentle echoes in the night. These suburban stars move at relaxed, wandering speeds, influenced only by the broad pull of the halo. Some were born within the galaxy, swept outward by gravitational tides. Others arrived from far-off companions, their orbits stretched into long, graceful loops that slowly trace the outer darkness. Picture these stars as lanterns at the edge of a quiet town, spaced far apart, yet connected by shared motion beneath the same wide sky. And beyond these edges, the broader universe organizes galaxies into familiar families. Fact 21. Spirals with starlit arms. Among all the shapes in the universe, spiral galaxies may be the most enchanting. Their arms stretch outward in soft curls, glowing with young, newly formed stars. These arms are not solid structures, but patterns, regions where gas is gently compressed, giving rise to clusters of bright blue suns that illuminate the spiral with delicate radiance. As the galaxy rotates, the arms maintain their elegant form, moving like ripples across a pond rather than rigid spokes. Dust lanes thread through them, outlining their curves and offering material for the next generation of stars. The entire shape turns with patient grace, completing a rotation over hundreds of millions of years. Imagine a spiral galaxy as a cosmic flower, its petals unfurling in slow motion, shimmering softly against the dark. And just beyond the spirals, another class of galaxies glows with older, quieter light. Fact 22. Ellipticals made of old light. Elliptical galaxies drift through the cosmos like great glowing clouds, smooth, rounded shapes filled mostly with older stars. Unlike spirals with their graceful arms, ellipticals have no sharp structure, only a soft gradient of light that fades gently from the center outward. Their stars orbit in many directions, creating a warm, even glow that feels ancient and serene. These galaxies often form through mergers, their once distinct shapes blending into a single, harmonious whole. As a result, ellipticals tend to host fewer young stars. Much of their gas has already been stirred, used, or scattered. What remains is a tranquil city of mature suns shining with steady, amber tones. Imagine an elliptical galaxy as a quiet lantern suspended in the dark, round, gentle, and glowing with old cosmic memory. And next to these old giants, some galaxies wander in more unusual shapes. Fact 23. Irregulars that wander free. Irregular galaxies are the cosmic free spirits, drifting without the symmetry of spirals or the smoothness of ellipticals. They appear scattered, uneven, and whimsical, as though they were shaped by a playful breeze rather than orderly forces. Their stars gather in clumps, their gas forms unexpectedly bright pockets, and their dust weaves through them in wandering paths. These galaxies often arise from close encounters or gravitational nudges that disturb their structure. Some are small and bright, with active star formation. Others are faint and quiet, holding just a few lonely clusters. Because they lack a defined shape, each irregular galaxy feels like a unique sketch drawn across the sky. Picture these galaxies as cosmic doodles, charming, spontaneous, and full of youthful energy. And among the most striking irregular forms are the galaxies shaped by dramatic past encounters. Fact 24. Peculiars born from collisions. When galaxies pass close to one another, or collide outright, their shapes can twist into extraordinary forms. These are peculiar galaxies, dramatic, sculpted structures that bear the marks of cosmic interaction. Long tidal tails may stream outward like flowing ribbons, or loops of stars may wrap around the core in elegant arcs. The entire galaxy can look stretched, warped, or astonishingly asymmetric. Yet even in this distortion, there is beauty. Collisions often trigger bursts of new star formation, filling peculiar galaxies with glowing clusters and brilliant blue regions. Over time, these dramatic shapes evolve, settling into more familiar forms as gravity rebalances the stars and gas. Imagine a peculiar galaxy as a cosmic dance caught mid-step, its shape frozen in a moment of graceful upheaval. And from these spectacular collisions, some galaxies emerge small, quiet, and surprisingly resilient. Fact 25. Dwarfs that whisper softly. Dwarf galaxies are the gentle whispers of the universe. Small, faint, and often overlooked, yet profoundly important. They contain far fewer stars than the grand spirals and ellipticals, sometimes only a few million compared to the hundreds of billions in larger galaxies. Their light is subtle, like distant fireflies floating in the cosmic dark, each one glowing with quiet persistence. Many dwarf galaxies orbit larger ones, moving in slow, graceful arcs over billions of years. Their shapes vary widely. Some are round and smooth, while others are irregular clouds of stars. Because their gravity is weak, they are easily stirred or reshaped by nearby giants, leaving them delicate and easily disturbed. Imagine a dwarf galaxy as a small cottage on the outskirts of a vast city, humble but filled with its own kind of peace. And between the dwarfs and spirals lies a transitional form with its own gentle charm. Fact 26. Lenticulars between two worlds. Lenticular galaxies rest peacefully between the elegance of spiral galaxies and the simplicity of ellipticals. They have a flat, disc-like shape reminiscent of spirals, yet they lack the distinct arms that sweep outward in graceful curves. Their stars are older, their gas supplies depleted, leaving them calm and quietly glowing in golden tones. These galaxies often arise from spirals that have slowly exhausted or lost their gas, settling into a more tranquil state. Their disks remain smooth and well-ordered, and their central bulges glow steadily, like small suns behind frosted glass. They are transitional galaxies, neither youthful nor old, but gently balanced in between. Picture a lenticular galaxy as a polished stone, smooth, rounded, and softly luminous, shaped by time and gentle forces. And beyond these serene shapes lies a rare family of galaxies that appear like cosmic ghosts. Fact 27. Ultra-diffuse ghosts. Ultra-diffuse galaxies are some of the faintest known. Their stars spread so thinly that they seem barely there at all. They can be as large as the Milky Way in size, yet contain only a tiny fraction of its stars, a delicate scattering like powdered light drifting across a darkened room. To the eye, they look like soft smudges against the night sky. Their dimness makes them difficult to study, but what we know reveals a mysterious balance. Many appear dominated by dark matter, which holds their fragile structure together. Others show signs of past interactions, as though they were stretched and thinned by the pull of larger neighbors. Imagine an ultra-diffuse galaxy as a ghostly silhouette in the cosmos, present, yet gently fading into the silence around it. And farther ahead, some galaxies blaze with the opposite energy, furious bursts of starbirth lighting up the dark. Fact 28. Starburst cities. Starburst galaxies are the bustling cities of the cosmos, places where stars are born at an extraordinary pace. Their gas clouds collapse rapidly, forming clusters of bright, young stars that shine with youthful, blue-white brilliance. These galaxies glow intensely, their vibrant regions standing out like lanterns along a quiet shore. This burst of creation can be triggered by interactions, mergers, or the gentle inflow of fresh gas. For a brief period, cosmically speaking, the galaxy becomes a glowing workshop of starlight, its energy radiating far into the surrounding darkness. Eventually, the gas supply dwindles, and the galaxy returns to a calmer rhythm, its star-forming frenzy settling into a peaceful hum. Picture a starburst galaxy as a city lit for a festival, full of shimmer and activity before gradually drifting back into stillness. And beyond these bright worlds lie galaxies so faint, they seem sculpted from shadows. Fact 29. Low surface brightness. Seas. Low surface brightness galaxies are like gentle seas of starlight spread across vast distances. Their stars are so widely scattered that the galaxy appears soft and dim, difficult to detect even with powerful telescopes. Yet within this faintness lies a quiet majesty, an enormous realm where stars drift in open, tranquil solitude. These galaxies often contain large amounts of dark matter, which keeps their loose structures from drifting apart. Their slow rate of star formation means they grow quietly, shining with a subtle, understated glow. Observing them requires patience, as if waiting for the faintest light to reveal itself in mist. Imagine a low surface brightness galaxy as a calm, open ocean at twilight, wide, placid, and illuminated only by the gentlest reflections. And at the far opposite end of the scale, some galaxies grow to almost unimaginable proportions. Fact 30. Giants at the edge of imagination. Some galaxies become true giants, vast beyond ordinary comprehension. These colossal structures can stretch hundreds of thousands of light years across, containing trillions of stars. They dominate their regions of space, like majestic continents floating in the cosmic sea. Their gravity influences nearby galaxies, guiding their motions and shaping entire clusters. Many of these giants are enormous ellipticals formed through repeated mergers. Their light glows softly but steadily, the combined radiance of countless ancient suns. Others are immense spirals with sweeping arms that arc gracefully across astonishing distances. These giants act as anchors in the universe's grand design. Picture a giant galaxy as a celestial continent, expansive, ancient, and quietly powerful, resting at the edge of what feels possible. And nestled within one such galaxy is the gentle home we know best. Fact 31. A spiral. We live inside our Milky Way is a grand spiral galaxy, though we can only glimpse it from within. A bit like standing inside a forest and seeing the trees, but never the whole shape. Its arms sweep outward in slow, graceful curves, carrying billions of stars along gentle orbital paths. From Earth, we witness this structure as a soft, glowing band stretched across the night sky. Because we live inside one of its arms, the Milky Way feels intimate and familiar. Its light appears as a hazy river of stars, shimmering quietly from horizon to horizon. Yet behind that delicate glow lies a sprawling system more than 100,000 light years wide. Imagine our galaxy as a vast, twirling garden of starlight, and us as small travelers walking its inner pathways. And within this garden, our own sun rests in a peaceful corner. Fact 32. The sun's quiet neighborhood. Our solar system resides in a gentle region of the Milky Way, known as the Orion Arm, a small, calm spur between two larger spiral arms. Here, stars are spaced comfortably apart, giving our sun a serene and stable home. This quiet neighborhood is far from the galaxy's bustling core, offering a place where life could evolve undisturbed over billions of years. Nearby stars drift at leisurely speeds, keeping a respectful distance as they orbit the galactic center. Interstellar dust and gas form faint clouds, soft and sparse, painting the region with subtle hues. It is an unhurried corner of the cosmos, not too crowded, not too empty. Picture this neighborhood as a peaceful countryside on the outskirts of a great cosmic city, where the nights are calm and the starlight gentle. And from this quiet place, long lanes of galactic dust stretch across the sky. Fact 33. The lanes of dust, threaded through the Milky Way, are long, dark lanes of interstellar dust, delicate clouds that drift between the stars. They may seem like shadows against the galaxy's bright background, but they are full of potential. Within these dusky regions, gas and dust gather, cool, and eventually form new stars and planets. These are the nurseries where future suns quietly wait to be born. The dust absorbs starlight, creating soft silhouettes that trace the galaxy's spiral arms. When viewed from Earth, these lanes appear as gentle breaks in the Milky Way's glow, adding depth and texture to the night sky. At infrared wavelengths, however, they shine faintly with their own warmth. Imagine these dust lanes as winding paths of twilight weaving through the galaxy, calm, dark, and full of hidden promise. And deeper within them lies the next stage of stellar creation. Fact 34. Stars born in gentle nurseries. Within the Milky Way's dust lanes lie vast, cool clouds where new stars quietly take shape. These stellar nurseries are peaceful realms, shielded from harsh radiation by thick blankets of dust. Inside, gravity slowly gathers gas into dense pockets, where temperatures rise just enough for nuclear fusion to spark a newborn star's first glow. These births are not sudden, but gradual, unfolding over millions of years in soft, hidden chambers of the galaxy. Clusters often form together, a family of stars emerging from the same cloud and drifting out into the galaxy like siblings leaving home. Some remain bound for life. Others wander off into the wider cosmic fields. Imagine these nurseries as warm cradles tucked deep within the galactic folds, each holding the faint promise of future suns. And as these stars grow, they lend their light to the old heart of our galaxy. Fact 35. The central bulge's old light. At the center of the Milky Way sits a rounded bulge of ancient stars, glowing with a soft amber warmth. These stars were born long before our sun, their lives unfolding in eras when the galaxy itself was still young. Their orbits are tangled and multi-directional, creating a gentle swarm of motion that blends together into a steady, golden radiance. The bulge is thick with stellar density. Stars crowd together far more closely than in our solar neighborhood. Yet despite this busyness, the region glows with a kind of quiet dignity, shaped by billions of years of cosmic evolution. It is the Milky Way's memory vault, holding the stories of its earliest formation. Picture the central bulge as a luminous ember nestled at the galaxy's core, warm and enduring. And stretching from this glowing heart is another striking feature shaped by time and motion. Fact 36. The bar that shapes our sky. Running through the center of the Milky Way is a long, subtle bar of stars, a graceful structure that helps shape the flow of gas and the formation of spiral arms. This bar acts like a cosmic bridge, guiding material inward toward the core and gently stirring the motions of the galaxy's inner regions. Its stars orbit together in elongated paths, moving in a slow, coordinated rhythm. Though we cannot see the bar directly from Earth, its influence is unmistakable in the way the spiral arms curve and the way gas streams toward the center. The bar helps maintain the galaxy's structure, balancing the motions that keep stars in their sweeping orbits. Imagine this bar as a soft beam of starlight stretching across the Milky Way's heart, quiet yet powerful in its guidance. And beyond this central architecture, ancient wanderers circle the galaxy from afar. Fact 37. The halo of ancient wanderers. Encircling the Milky Way is a vast halo containing some of the oldest stars our galaxy has ever known. These ancient suns travel on long, looping orbits, taking billions of years to complete a single journey around the galactic center. Their paths are often inclined and irregular, crossing above and below the disk like quiet wanderers moving through a grand cathedral. These stars formed early in the galaxy's history, carrying with them the chemical signatures of a youthful universe. Many shine faintly, their fuel slowly dwindling after an age of endurance. In the halo, they drift in near solitude, each one a tiny beacon glowing across immense emptiness. Imagine this halo as a soft, shimmering shell around the Milky Way, a place where time stretches long and the stars gently remember the beginning. And scattered throughout this halo are clusters that glow like distant, suspended fireflies. Fact 38. Globular clusters, like frozen fireflies. Globular clusters are tight spheres of stars, bound together by gravity in one of the most beautiful arrangements found in the galaxy. Each cluster holds hundreds of thousands of ancient stars, packed so closely that they appear like shimmering globes of light. These clusters orbit far from the galactic center, drifting through the halo in slow, stately arcs. Their stars are among the oldest in existence, fossils of a bygone cosmic era. Their golden glow reflects a time when the Milky Way was still gathering its shape. From afar, a globular cluster looks like a frozen burst of sparks, a moment of brilliance suspended in the dark. Imagine standing beneath a sky filled with warm lanterns gathered in a perfect sphere, each one glowing with ancient memory. And beyond these clusters, faint trails of stars tell stories of galaxies long since lost. Fact 39. Streams from long lost. Galaxies, woven through the Milky Way's halo, are long, delicate streams of stars, remnants of smaller galaxies that were gently absorbed over billions of years. As these dwarf galaxies drifted too close, our galaxy's gravity slowly pulled them apart, their stars unspooling into graceful ribbons that wrap around the Milky Way like soft, glowing threads. These streams carry the histories of their original homes, preserving patterns of motion that reveal their past journeys. Even after their parent galaxies dissolve, the stars continue along their inherited paths, creating quiet, starlit trails that circle the Milky Way. Picture these stellar streams as trails of petals drifting behind a slowly turning dancer, remnants that move with quiet beauty long after the original shape has faded. And at the core of it all, the Milky Way itself moves in a gentle, unified rotation. Fact 40. The Milky Way's gentle rotation. Though the Milky Way appears still from our vantage point, the entire galaxy is slowly turning, like a vast wheel drifting through the quiet of space. Every star, including our Sun, follows a patient orbit around the galactic center. Our solar system takes about 230 million years to complete a single circuit, a journey known as a galactic year. In that time, continents shift, species rise and fall, and worlds transform beyond recognition. Yet through all this change, the galaxy's rotation remains smooth and steady. Stars in the inner regions travel more quickly, while those farther out glide at a calmer pace. Dark matter helps maintain this consistency, shaping the rotation so that the galaxy turns as one harmonious whole. Imagine this rotation as a soft cosmic lullaby, guiding every star in gentle, predictable motion. And accompanying our galaxy in this slow dance is a majestic neighbor just beyond our reach. Fact 41. The Andromeda Neighbor. The Andromeda Galaxy is the Milky Way's largest and closest galactic companion, a grand spiral that mirrors our own in many ways. Situated roughly 2.5 million light-years away, it shines faintly in our night sky, visible from dark locations as a delicate smudge of light. Yet that tiny smudge represents a vast world containing 1 trillion stars, swirling in elegant, curving arms. Andromeda moves slowly toward us, drawn by gravity in a quiet, inevitable drift. In billions of years, the two galaxies will gently merge, forming a new, larger galaxy. Even now, both systems influence each other's motions, connected by a shared gravitational bond across unimaginable distances. Imagine Andromeda as a distant island of light across a calm cosmic sea, close enough to sense, far enough to dream about. And near this luminous neighbor lies another, smaller companion that adds its own charm to the local group. Fact 42. The Triangulum Companion. The Triangulum Galaxy, also known as M33, is the third major member of our local group. A delicate spiral smaller than both the Milky Way and Andromeda, yet rich with beauty. Its arms contain bright regions of star formation, glowing softly with youthful light. Though modest in size, it plays an important role in the gravitational interplay of our galactic neighborhood. Triangulum orbits near Andromeda, possibly bound to it in a long, slow dance. Its structure is more open and loosely wound than the grand spirals, giving it a gentle, airy appearance. Its starlit regions shimmer like scattered blossoms drifting along its arms. Picture Triangulum as a smaller lantern floating beside two great beacons, subtle, graceful, and quietly contributing to the harmony of our cosmic family. And beyond it, even smaller galaxies swirl gently around the Milky Way's embrace. Fact 43. The Magellanic Clouds. Orbiting the Milky Way are two small but luminous companions, the large and small Magellanic Clouds. These dwarf galaxies drift near us like gentle lanterns hung against the southern sky. Their shapes are irregular and soft-edged, as though carved by wandering breezes rather than precise structure. Each contains glowing pockets of star formation, clusters, and swirling clouds of gas. The large Magellanic Cloud hosts one of the most active stellar nurseries in our galactic neighborhood, the Tarantula Nebula, where young stars ignite in bright clusters. The small Magellanic Cloud is quieter, its stars arranged in loose drifting patterns. Together, they circle the Milky Way along long, graceful orbits, slowly shaped by our galaxy's tidal pull. Imagine these clouds as glowing companions walking beside us through the cosmic night, steady and comforting in their presence. And connecting these satellites to our galaxy is a flowing bridge of stars and gas. Fact 44. Dwarf spheres in the dark. Surrounding the Milky Way are many tiny dwarf spheroidal galaxies, faint, delicate collections of stars that orbit like silent beads on invisible strings. These galaxies are dimmer than the Magellanic Clouds, so subtle that many remained unknown until the modern era. Their stars are old and quietly glowing, arranged in round, diffuse shapes without clear structure. Dwarf spheroidals contain very little gas, and few, if any, new stars are born within them. Instead, they drift serenely through space, their motions determined by the Milky Way's gravitational embrace. They are fragile, easily stirred or stretched by tidal forces, leaving faint hints of their passage across the halo. Imagine these tiny galaxies as soft candle flames, small, flickering, and ancient, gliding through the darkness around our cosmic home. And between them and the Milky Way lies a delicate thread connecting galaxies together. Fact 45. Tidal bridges of starlight. When galaxies interact, faint bridges of stars and gas can form between them, long translucent streams that link their shapes like strands of silk. The Milky Way and the Magellanic Clouds share one such feature: the Magellanic Bridge, a stretching ribbon of hydrogen gas sprinkled with scattered stars. It is a gentle reminder that galaxies are not isolated islands, but communicating partners in a larger cosmic dance. These bridges form when gravity tugs at one galaxy's outskirts, pulling material outward in graceful arcs. Though fragile, they can persist for hundreds of millions of years, marking the path of past encounters and hinting at future ones. Some even give birth to new stars along their length, lighting the bridge with tiny newborn suns. Picture a tidal bridge as a soft glimmer across an otherwise empty sky, a whisper of connection between distant worlds. And beyond these connections, entire groups of galaxies drift together through space, moving in shared harmony. Fact 46. The dance of local group galaxies. Within the local group, each galaxy moves in a quiet, choreographed drift shaped by gravity's gentle guidance. The Milky Way, Andromeda, Triangulum, and dozens of dwarf galaxies form a loose, cosmic family, traveling together through the universe. Though the distances between them are enormous, their motions are connected, as if they were dancers circling the same vast, invisible stage. Over billions of years, their paths shift and weave, drawing them gradually closer or easing them farther apart. Some dwarfs fall into tighter orbits around the giants, while others skim the edges and drift away again. Nothing is hurried. Everything unfolds with the slow patience of cosmic time. Imagine the local group as a cluster of softly glowing lanterns drifting down a dark, gentle river, each separate, yet carried forward by the same current. And in this drifting family lies a quiet hint of the future. Fact 47. The future, Milkdromeda. Far into the cosmic future, about 4 billion years from now, the Milky Way and Andromeda will meet in a slow, graceful merger. Though it sounds dramatic, the encounter will unfold gently across billions of years, with stars passing mostly through empty space and interacting only through gravity. Instead of chaos, it will resemble a long, serene blending of two great spirals. Their arms will stretch and warp, creating luminous tides of stars. Over time, their cores will spiral toward one another, eventually uniting in a new galaxy, often nicknamed Milkdromeda. This future galaxy will likely be large, rounded, and softly glowing, an evolved shape born from the joining of two grand spirals. Imagine the night sky of that era, Andromeda growing brighter, larger, and finally merging into our own starry home. And even today, small galaxies already drift quietly around us, shaping the Milky Way's motion with gentle persistence. Fact 48. The quiet drift of satellites. Around the Milky Way, dozens of small satellite galaxies move in slow, elegant orbits. Each one traces a long, looping path through the halo, passing close and then drifting far away again over hundreds of millions of years. Their motions are subtle, influenced by dark matter, the galaxy's mass, and the quiet tug of nearby companions. Some satellites, like the Magellanic Clouds, are bright enough to see with the naked eye. Others remain dim and ghost-like, detectable only with sensitive instruments. They act as gentle sculptors, stirring the Milky Way's outer regions and leaving behind tidal streams that mark their journeys. Picture these satellites as tiny boats gliding around a great glowing island, each leaving faint ripples on the cosmic sea as they pass. And deeper inside this sea, gravity shapes the very orbits galaxies follow. Fact 49. The sculptor of orbits. Within the Milky Way, gravity is the quiet sculptor that guides every orbit. From the gentle drift of distant halo stars to the smooth, patient loops of the sun, it acts without sound or haste, shaping the paths of billions of stars with a steady, invisible hand. Each orbit is a story written over millions of years, defined by distance, mass, and the soft pull of the galactic core. These orbits are not perfect circles, but graceful ellipses of many shapes, each one responding to the galaxy's uneven distribution of matter. Stars weave in and out, rising above the disk and sinking back through it like waves rolling across a starlit ocean. The result is a dynamic yet peaceful motion, a quiet choreography unfolding on a grand scale. Imagine these orbits as threads of light woven into a vast tapestry, each one contributing to the galaxy's gentle motion. And beyond this elegant weaving lies the deeper gravitational heart of our cosmic neighborhood. Fact 50. The group's invisible center. The local group, with all its galaxies and drifting companions, has a shared center of gravity, an invisible point that lies somewhere between the Milky Way and Andromeda. This center isn't marked by any star or beacon. Instead, it is the balance point created by the masses of all the galaxies combined. Everything in the group orbits this unseen location, moving in soft, interlocking paths. Because Andromeda is slightly more massive than the Milky Way, this gravitational center lies a bit closer to Andromeda's side. Yet both galaxies pull strongly enough to keep the entire group bound together, drifting as one through the cosmic web. Even the smallest dwarf galaxies feel this shared pull, shaping their motions over billions of years. Imagine this center as a quiet point of equilibrium in a wide, star-filled meadow, unnoticed yet essential to the harmony of the landscape. And within this harmonious space, new stars continue to bloom from clouds of gas and dust. Fact 51. Star, nurseries, and cradles. Throughout galaxies, there are regions where gas cools and gathers into gentle clouds, forming the cradles of newborn stars. These nurseries are peaceful, shaded realms where starlight barely penetrates, allowing molecules to settle and bond in the comfort of darkness. Slowly, gravity draws these clouds inward until they fragment into dense pockets, the seeds of future suns. As these pockets collapse, warmth grows at their centers, and faint embryonic stars begin to glow. Some nurseries hold hundreds of young stars, bundled together like a litter of celestial kittens. Others form only a few, quietly nurturing them until they emerge into the brighter galactic world. Imagine these nurseries as soft blankets tucked deep in the arms of galaxies, holding the delicate promise of new light. And from these cradles, gas clouds glow with the subtle warmth of creation. Fact 52. Clouds that glow from within. Within galaxies, certain clouds of gas and dust light up from the inside, becoming grand, luminous nebulae. These glowing regions, called emission nebulae, shine because young stars embedded within them release gentle streams of energy. That light excites the gas around them, causing it to blush in soft reds, pinks, and purples. The result is a warm, ethereal glow, like lantern light behind a veil. These nebulae mark areas of ongoing creation where stars are still forming or have only just emerged from their dusty cocoons. The clouds themselves are delicate, shaped by starlight, winds, and gravity into pillars, wisps, and drifting waves. Over time, new stars sculpt the gas into ever-changing forms. Imagine a glowing nebula as a stained glass window in a cosmic cathedral, softly illuminated from within. And scattered throughout these bright clouds are clusters of freshly born blue stars. Fact 53. Fields of young blue suns. In the spiral arms of many galaxies, enormous fields of newly formed blue stars shine brightly against the surrounding darkness. These stars are young, hot, and full of energy, burning through their fuel quickly, but radiating brilliant light while they last. Their intense blue hues come from their high temperatures, making them some of the most dazzling objects in the galactic landscape. Clusters of these youthful suns form from dense clouds, emerging together in shimmering groups. Their light illuminates nearby dust and gas, giving the spiral arms their characteristic glow. Though their lives are relatively short, they play an essential role in shaping their galaxies, stirring the surrounding medium with strong winds and gentle radiation. Imagine these blue stars as vibrant wildflowers blooming along a galactic path, brightening everything around them for a brief, beautiful moment. And as time passes, these stars gradually mellow, settling into quieter phases of life. Fact 54. The slow aging of stars. As stars grow older, they settle into more peaceful rhythms. Their brilliant blue tones fade into softer whites and yellows, and their energy output becomes steadier and gentler. Most stars spend the majority of their lives in this calm, middle stage, quietly fusing hydrogen and shining with a consistent, comforting glow. The sun, too, is in this tranquil chapter of its life. As they age, stars drift farther from the regions where they were born, spreading out across the galaxy like wandering travelers. Their changes are slow and graceful, unfolding over billions of years. Their shifting colors and temperatures tell the story of stellar evolution written in gentle gradients of light. Imagine an aging star as a candle moving from its brightest flame to a warm, steady glow, enduring, familiar, and serene. And eventually, these stars grow into red giants, embers glowing softly in the vast night. Fact 55. Red giants, like warm embers. As stars near the end of their peaceful middle years, they begin to swell into red giants. Vast, luminous bodies glowing with the warm colors of sunset. Their outer layers expand, becoming cool and diffuse, while their cores contract and heat up. These giants shine with a deep, comforting red-orange light, like embers stirring in a quiet hearth. Though they appear gentle, red giants are enormous, sometimes growing large enough to engulf nearby planets. Yet their transformation unfolds slowly, spanning millions of years. Their winds carry elements forged in their interiors outward into space, enriching their galaxies with the building blocks of future stars and worlds. Imagine a red giant as a great, glowing lantern drifting calmly through the galaxy's night, marking the soft turning point of a star's life. And when these luminous embers fade, they leave behind powerful gifts for the cosmos. Fact 56. Supernova seeds of renewal. When certain stars reach the end of their lives, they collapse and explode in brilliant supernovae, dazzling bursts of light that briefly outshine entire galaxies. Though the word explosion sounds harsh, the process is a vital part of cosmic renewal. In these moments, heavy elements like iron, gold, and oxygen are cast into space, seeding galaxies with the materials that make planets, oceans, and life itself possible. Supernovae release gentle shockwaves that compress nearby gas clouds, encouraging new stars to form. Their dust enriches the interstellar medium, transforming ordinary regions into fertile grounds for creation. Even as the brilliant flare fades, the enriched remnants drift on, participating in the galaxy's next cycles of birth and change. Picture a supernova as a cosmic flower blooming in a brilliant flash, scattering its seeds across the universe with one radiant, transformative moment. And in the glowing aftermath, clouds of dust give rise to some of the galaxy's most hauntingly beautiful shapes. Fact 57. Nebulae. As galactic gardens, nebulae, whether formed from stellar births or stellar endings, are the great gardens of galaxies. Their drifting layers of gas and dust create landscapes of color and form, sculpted by light, gravity, and time. Some are vast and bright, glowing in soft reds and blues. Others are dark and mysterious, veiling the light behind them like curtains of cosmic smoke. Within these nebulae, stars are born, live, and die, contributing their materials to the next generation. The shapes we see in these clouds, pillars, arches, waves, are temporary sculptures, always changing as winds and light reshape them. Over millions of years, they disperse, scattering their enriched material across the galaxy. Imagine a nebula as a lush, ever-changing garden of starlight, where creation and transformation flow gently together. And carried within these clouds are the chemical memories of ancient stars. Fact 58. Metals from stellar memories. Every star holds the memory of the universe within its light, but especially in its elements. When stars live and die, they forge heavier atoms, carbon, oxygen, iron, and countless others in their glowing hearts. Astronomers call these elements metals, even though many aren't metals at all. What matters is that they are the fingerprints of stellar history, carried from one generation to the next. As stars shed their outer layers or burst in supernovae, these precious elements drift into space. Over millions of years, they mix with cold gas clouds, enriching them with the ingredients needed for planets, oceans, and, someday, life. Each new star inherits this ancestry, its composition whispering clues about long-lost stellar families. Imagine these elements as soft echoes of ancient suns, sprinkled throughout the galaxy like tiny seeds of memory. And in galaxies where these elements grow scarce, star formation gently slows. Fact 59. Quiet starvation in old galaxies. Some galaxies gradually run out of the cool gas needed to form new stars. Over time, their star birth slows to a quiet halt, leaving them filled mostly with older, redder, and calmer stars. This gentle fading isn't sudden or dramatic. It's more like a slow lowering of lights in a peaceful room. Without fresh gas drifting inward, the galaxy simply settles into a long twilight. These quenched galaxies still shine, but their glow grows softer with each passing age. They may have lost their gas through past collisions, intense starburst periods, or internal processes that heated the gas beyond its ability to collapse. What remains is a serene landscape of aging stars, drifting without the bright blue sparkle of youth. Imagine walking through a quiet old town where the hustle has faded, but warmth remains, steady and enduring. And in other galaxies, spiraling arms help recycle gas, giving rise to new life again and again. Fact 60. Renewal in spiraling arms. In spiral galaxies, the sweeping arms serve as engines of renewal. As the disk slowly rotates, these arms act as gentle compression waves, nudging clouds of gas and dust just enough to spark new star formation. The stars themselves drift freely in and out of the arms, but the pattern remains, a beautiful, ongoing rhythm of creation. Within these arms, bright clusters of young stars glow like lanterns guiding the galaxy's path. Dust lanes trace the curves, hiding newborn suns and hinting at the next wave of creation. Even as older stars move outward, the arms continue their quiet work, nurturing fresh generations and weaving the galaxy's shimmering tapestry. Imagine a spiral arm as a soft, glowing trail through a starry meadow where new life continually blossoms. And as we move through these arms, galaxies sometimes meet and reshape one another in gentle cosmic encounters. Fact 61. When galaxies meet, across the vast stretches of the universe, galaxies sometimes drift close enough to feel each other's gravity. When they do, their shapes begin to change in slow, graceful motion, long before they truly touch. Stars shift into new orbits, gas clouds stretch into delicate arcs, and faint tides of starlight begin to unfurl. These encounters unfold not over moments, but over millions of years, like two dancers approaching from afar. From our perspective, such meetings look serene despite their scale. Most stars pass by without colliding, gliding past one another as space easily accommodates their paths. What changes most are the patterns, the swirls, the flows, the soft architecture of the galaxies themselves. Imagine two galaxies drifting closer in the night, their edges brushing like gentle waves, meeting on a quiet shore. And as they draw nearer, beautiful structures bloom from the tug-of-war between them. Fact 62. The stretch of tidal tails. When the gravity of one galaxy tugs strongly at another, luminous tails of stars and gas can stretch outward, shimmering like celestial ribbons. These tidal tails appear as elegant, sweeping arcs that curve away from the main galaxy, marking the path of the interaction. Some extend for hundreds of thousands of light years, thin and delicate as threads of silk. Within these tails, clusters of new stars can form, lit by the gentle compression of drifting gas. Over time, the tails may fade, merge, or form small dwarf galaxies of their own, tiny offspring born from the gravitational play between larger systems. Even after the main galaxies have settled into new shapes, these tails remain as lasting signatures of their encounter. Picture a tidal tail as a luminous brushstroke across the cosmic canvas, painted by the quiet pull of gravity. And when two galaxies embrace even more tightly, they begin to blend into something entirely new. Fact 63. Mergers that reshape worlds. When galaxies finally merge, the process is astonishingly slow and breathtakingly graceful. Their stars pass through one another without touching, guided only by smooth gravitational currents. Cores spiral inward, arms twist and fold, and clouds of gas collide softly, sparking bursts of newborn stars. Over billions of years, the two galaxies lose their separate identities, settling into a single, unified shape. The result may be an enormous elliptical galaxy, or something more unusual depending on the collision's angle and momentum. Mergers bring change, but not turmoil. They are part of the natural evolution of galaxies, a gentle rejuvenation that stirs old stars and gives rise to new ones. Imagine two vast galaxies blending like colors in a watercolor painting, slowly swirling into harmony. And out of these grand interactions, new rings and shapes sometimes arise, beautiful and fleeting as cosmic ripples. Fact 64. Rings from cosmic impacts. Sometimes, when a smaller galaxy passes directly through a larger one, it sends waves of motion rippling through the disk, like a pebble dropped into still water. These waves compress gas into circular patterns, creating striking ring galaxies. The rings glow with bright, newborn stars, expanding outward in slow, gentle ripples over millions of years. Though they appear dramatic, ring galaxies are temporary, shimmering snapshots of a brief cosmic phase. As the waves travel outward, the ring grows wider and fainter, eventually blending back into a more familiar shape. The intruding galaxy often continues on its path, drifting quietly into the darkness after igniting this momentary, luminous bloom. Imagine a ring galaxy as a celestial ripple frozen in time, glowing softly as it spreads across the night. And in other interactions, galaxies don't pass through one another. They slowly reshape each other from the outside in. Fact 65. Bridges across the void. When two galaxies pull gently at each other, stars and gas may form graceful bridges connecting them, long, translucent streams that reach across the darkness like arms outstretched. These bridges reveal the invisible pull between galaxies, tracing the exact contours of their shared gravitational bond. They can last for hundreds of millions of years, slowly drifting, stretching, and reshaping as the galaxies continue their dance. Within these bridges, new stars sometimes form, their light flickering like tiny lanterns along a vast walkway. Other times, the bridge remains faint and ghost-like, a tenuous trace of the interaction. Eventually, the galaxies may merge, drift apart, or settle into stable orbits, but the bridges remain as gentle reminders of their meeting. Picture these bridges as soft pathways of starlight hanging across the void, delicate, peaceful, and impossibly wide. And sometimes, one galaxy quietly pulls stars from another in a slow, graceful exchange. Fact 66. Quiet cannibalism. Large galaxies often grow by absorbing smaller ones in a process known as galactic cannibalism. Though the reality is far more gentle than the name suggests. As a dwarf galaxy drifts too close, the stronger gravity of the larger galaxy gradually pulls it apart, star by star. Over millions of years, the smaller galaxy's identity fades, its stars becoming part of the larger system's halo or streams. This quiet cannibalism helps galaxies evolve, adding fresh stars, new elements, and updated structure. The process is serene, more like a soft blending than an abrupt consumption. Many of the Milky Way's halo stars arrive this way, bringing with them the chemical signatures of long-lost homes. Imagine this process as a delicate folding of one starlit cloth into another, merging patterns until only one gentle tapestry remains. And after these quiet absorptions, faint trails of torn-away stars continue to drift through the dark. Fact 67. Threads of stars torn free. When galaxies interact, not all stars remain bound to their original homes. Some are gently pulled outward, forming long, delicate threads that trail behind like wisps of silk caught in a breeze. These stellar streams drift through intergalactic space, tracing the paths of past encounters with quiet elegance. Though faint, they carry with them the ancient stories of the galaxies they once belonged to. Over time, these threads spread out, their stars continuing on shared orbits that preserve the memory of their original motion. Astronomers can follow these patterns like footprints across the cosmos, uncovering the history of collisions, mergers, and close encounters. Imagine these stellar threads as soft ribbons drifting behind a slow-moving dancer, luminous, and ephemeral. And when galaxies collide more fully, these threads ignite bursts of new starlight deep within their cores. Fact 68. Bursts of new life after collisions. When two galaxies come together, the gentle shock of their meeting compresses gas clouds and ignites fresh waves of star formation. These bursts can fill a galaxy with clusters of bright young stars, their blue-white light shimmering like sparks from a quiet fire. Though the process unfolds slowly, on cosmic timescales, it feels like a sudden bloom, a galaxy briefly flowering with youthful radiance. These starbursts can reshape a galaxy's appearance, lighting up regions that were once dim and stirring gas into swirling, luminous patterns. Over time, the bursts fade as the gas is used up or dispersed, leaving behind new generations of stars that will quietly orbit for billions of years. Imagine a galaxy after a collision glowing with newfound life, like a garden blooming after a soft summer rain. And deep within these newly energized galaxies, their hearts grow brighter still. Fact 69. Hearts reignited. In the aftermath of a galactic interaction, material often flows inward toward a galaxy's core. This gentle infall of gas can awaken the central region, feeding the stars near the heart, and sometimes even reactivating the supermassive black hole at the center. When this happens, the core glows more brightly, shining with renewed energy that can outshine the entire galaxy. This reignition is not violent, but steady, a soft brightening that reflects the return of fuel to the central engine. Some galaxies become active for a time, releasing jets or subtle waves of radiation before gradually returning to a quiet state once the gas supply diminishes. Imagine a galactic heart rekindled, glowing like an ember stirred by a passing breeze, warm, bright, and full of ancient power awakening once again. And after the brightness subsides, galaxies settle into gentle calm, letting the echoes of their encounters fade. Fact 70. Calm after cosmic storms. After galaxies twist, stretch, and glow from their encounters, a long period of calm eventually returns. Their shapes, once distorted by tidal forces, begin to soften and settle. Stars disperse into new orbits, gas clouds relax into equilibrium, and the luminous echoes of collision fade gently into the background. What remains is a galaxy renewed, reshaped by experience yet peaceful once again. Over billions of years, the scars of interaction blur until they become indistinguishable from natural structure. The galaxy drifts onward, carrying within it the quiet memory of the meeting. Its stars continue their patient journeys, circling the center in serene harmony. Imagine a galaxy after such a storm, like a lake after rainfall. Ripples smoothing, reflections returning, the night once again still. And at the quiet heart of many galaxies lies a presence of incredible gravity and grace. Fact 71. Giants in the dark. Hidden at the centers of most galaxies are supermassive black holes, giants made not of light, but of gravity itself. They sit silently, often unnoticed, their influence shaping the orbits of stars around them. These black holes can be millions or even billions of times the mass of the Sun, yet they occupy surprisingly small regions, dense enough to curve space like a deep, gentle well. Most of the time, they rest in quiet darkness, feeding very little and giving away even less. Their presence is known not through their light, for they emit none, but through the steady, coordinated motion of the stars that orbit nearby. These stars dance in fast, tight paths, revealing the hidden mass at the galaxy's core. Imagine such a black hole as a silent anchor, unseen yet essential. holding the galaxy's heart in calm, steady balance. And when these giants do feed, a different kind of cosmic light appears. Fact 72. The rhythm of accretion. When gas drifts too close to a supermassive black hole, it forms a swirling disk of material known as an accretion disk. This disk warms as it spirals inward, glowing brightly in soft tones of ultraviolet and X-ray light. The process unfolds in a slow, rhythmic pattern. Gas falls inward, shines briefly, and vanishes beyond the event horizon. It is one of the universe's most serene yet powerful cycles. The accretion disk spreads its light across the galaxy, illuminating the central region with a luminous, whispering glow. Sometimes, the disk thickens with new material, brightening the core for thousands of years before dimming again. This ebb and flow forms the quiet heartbeat of active galaxies. Imagine an accretion disk as a glowing whirlpool, its light swirling softly in a patient spiral around the hidden giant. And from this gentle rotation, some galaxies release elegant streams of light that stretch far into the darkness. Fact 73. Jets that whisper across space. In some galaxies, the swirling material around a supermassive black hole creates powerful, narrow jets of energy that stream outward into the darkness. Though the processes that form these jets are complex, the result is surprisingly graceful. Long beams of light and particles that stretch for thousands, sometimes millions, of light years. From afar, they look like cosmic whispers, delicate lines painted across the void. These jets travel at nearly the speed of light, carrying energy far from the galaxy's core. They shape the surrounding gas, carve faint cavities in intergalactic space, and gently warm the clouds they pass through. Yet despite their incredible power, they remain steady and elegant, shining softly against the night. Imagine a galaxy with a luminous thread extending from its center, a quiet, unwavering beam reaching into eternity. And from even farther away, some galaxies shine like bright lighthouses guiding us through cosmic history. Fact 74. Quasars as ancient beacons. Quasars are some of the brightest objects in the universe. Galaxies, whose central black holes are feeding with extraordinary intensity. As matter spirals inward, the accretion disk glows with dazzling brilliance, outshining the rest of the galaxy by a staggering margin. To us, these distant lights appear as tiny points, far away and long ago. Most quasars lived in the early universe, when galaxies were young and rich in gas. Their glow traveled billions of years to reach us, carrying messages from a time when the cosmos was still forming its grand design. Even though we see them as they once were, their light still warms the present, like lanterns glowing from across an ancient sea. Imagine a quasar as a cosmic lighthouse shining through time, its brightness a soft guide through the universe's youthful darkness. And long after such activity fades, many black holes settle into a deep, gentle sleep. Fact 75. Sleeping black holes. While some black holes blaze with activity, most rest quietly, consuming little or no material at all. These sleeping giants sit patiently at the centers of their galaxies, scarcely emitting any light. Their presence is felt only through gravity, the calm, steady force that shapes the orbits of nearby stars and gas. They wait in serene dormancy, as silent as stones beneath a moonlit lake. Every so often, a drifting cloud or wandering star may pass too close, briefly awakening the black hole in a soft flare of light. But most of the time, they remain peaceful, allowing galaxies to evolve gently around them without interruption. Imagine a sleeping black hole as a deep well of stillness, perfectly calm, quietly holding the galaxy's center in its embrace. And around these silent hearts, dust and gas swirl in soft, shadowed shapes that hint at hidden mysteries. Fact 76. Dust-laden cores. Even in galaxies with quiet central black holes, the inner regions often contain thick clouds of dust that drift like soft shadows. These dust lanes wrap around the core in graceful, twisting shapes, obscuring parts of the central glow and giving galaxies a mysterious, layered beauty. Though they dim the starlight, they also protect cooler regions where gas can gather and new stars may someday form. This dust, created from the remnants of old stars, carries the memories of countless stellar lifetimes. It absorbs light and re-emits it gently in infrared wavelengths, warming the core with a soft, unseen glow. In some galaxies, these dust-laden centers look like swirling storms. In others, they resemble calm, dark clouds suspended in golden light. Imagine the core of a galaxy veiled in a delicate scarf of cosmic dust, soft, shadowed, and full of quiet promise. And within these hidden interiors, stars often dance in tightly bound orbits near the very center. Fact 77. Stars dancing at the center. In the innermost regions of galaxies, stars move in fast, intricate patterns, their orbits influenced by the massive black hole at the heart. These orbits can be tight and elongated, forming a kind of cosmic choreography known only to stars and gravity. Each star traces its path with silent precision, moving at tremendous speeds, yet appearing serene from a distance. These central stars are often young and bright, formed from gas that drifted inward and settled near the black hole. Their motion tells astronomers the mass of the hidden giant they orbit, revealing the presence of something far more massive than any single star. Over time, their orbits shift subtly, shaped by the gentle tug of gravity and the flow of nearby gas. Imagine peering into the galaxy's core and seeing stars whirl in delicate, swirling trajectories, a shining ballet performed in the deepest night. And just outside this intricate dance, faint flares of light sometimes flicker and fade with graceful regularity. Fact 78. Gentle flares of light. Even sleeping black holes occasionally send out soft flares of light when small amounts of gas wander too close. These flares are brief, quiet brightenings, delicate pulses that illuminate the core for only a short time before fading back into shadow. They may occur when a passing cloud brushes the accretion disk or when a star sheds a thin veil of material into the black hole's reach. The flares are subtle, often visible only with sensitive instruments, yet they reveal the ongoing, slow conversation between the black hole and its surroundings. Each pulse is a whisper of activity, a reminder that even the quietest giants occasionally stir. Imagine these flares as tiny sparks glowing in a darkened room, brief, soft, and full of quiet significance. And from these gentle pulses, some galaxies reveal even greater radiance through their active, glowing cores. Fact 79. The glow of active galaxies. Some galaxies shine with extraordinary brilliance at their cores, their central black holes feeding steadily on drifting gas. These are active galaxies, and their hearts glow with a soft yet powerful radiance that can outshine all their surrounding stars combined. Light from the accretion disk spills outward in gentle waves, illuminating dust, warming gas, and painting the inner region with shimmering hues. Though these galaxies appear bright and intense, their activity follows calm, predictable rhythms. The flow of gas onto the black hole ebbs and swells, creating variations in brightness that reveal the structure of the core. To distant observers, these changes look like a galaxy quietly breathing, inhaling and exhaling light over cosmic years. Imagine an active galaxy as a lantern with a warm, flickering flame at its center, luminous, steady, and alive with gentle motion. And beyond these radiant hearts, galaxies connect to an even larger tapestry that spans the universe. Fact 80. Shadows that shape the whole. Even though dark matter cannot be seen, its immense gravity shapes the structure of galaxies from the outside in. It forms the invisible framework around which stars, gas, and dust gather, influencing the rotation, size, and stability of every galactic form. Without this unseen mass, galaxies would not hold together. Their stars would drift apart like sparks on the wind. Dark matter halos extend far beyond the visible edges, creating a gentle, encompassing shadow. This shadow is not empty, but full of quiet influence, guiding the orbits of satellites and sculpting the galaxy's long-term evolution. It is the silent partner to every luminous structure in the universe. Imagine dark matter as a soft, invisible hand cupped around each galaxy, steadying it without ever revealing itself. And as galaxies rest in these shadowed cradles, they gather into grand patterns that stretch across space. Fact 81. Cosmic filaments, like threads of night. Galaxies do not drift alone. They lie along immense cosmic filaments, vast, thread-like structures woven from dark matter and glowing with clusters of distant galaxies. These filaments form the scaffolding of the universe, stretching across hundreds of millions of light years. Between them lie immense cosmic voids, silent and nearly empty, giving the universe its delicate, lace-like pattern. Along these threads, galaxies move slowly toward clusters, flowing like gentle currents along a river of gravity. The filaments connect superclusters, walls, and groups, forming a cosmic web that holds the entire universe together. Even from afar, the structure appears serene, orderly, and mesmerizing. Imagine the cosmic web as a tapestry spun from the faintest strands of night, with galaxies like tiny beads shining along every thread. And within the spaces between these filaments lie the quietest regions of all, the vast, peaceful voids. Fact 82. Voids, vast and silent. Between the great filaments of the cosmic web lie immense voids, vast, near-empty expanses where few galaxies reside. These regions stretch for hundreds of millions of light years, quiet as untouched snowfields in the night. Within them, only a handful of lonely galaxies drift, their light barely brushing the darkness around them. Voids are not truly empty. They hold faint traces of gas, wisps of dark matter, and rare islands of starlight. But compared to the bustling filaments, they feel open, calm, and profoundly still. Their emptiness reveals the universe's large-scale balance. Dense here, spacious there, a gentle rhythm of fullness and quiet. Imagine standing in a silent meadow beneath an endless night sky, feeling the vastness around you. That serene openness is what cosmic voids represent. And along their borders gather some of the largest structures in existence. Fact 83. Superclusters of light galaxies gather into clusters, and clusters themselves group into even grander structures known as superclusters. These enormous gatherings stretch across space like luminous continents, each containing tens of thousands of galaxies flowing through a shared gravitational landscape. They are not tightly bound, but gently associated, drifting together over cosmic ages. The Laniakea supercluster, which includes the Milky Way, spans more than 500 million light-years. Its name means immense heaven, a fitting description for such a colossal, softly glowing realm. Within it, galaxies follow graceful paths toward a central region of higher density, like rivers flowing gently downhill. Imagine a supercluster as a magnificent archipelago of galaxies scattered across a calm, dark sea, each island radiant with its own quiet life. Yet even these enormous formations belong to still larger walls and sheets woven throughout the cosmos. Fact 84. Walls that span the universe. Across the universe, galaxies and clusters align into enormous walls, vast, sheet-like structures that stretch for hundreds of millions of light years. These walls form the boundaries of cosmic voids, creating enormous honeycomb-like patterns when viewed on the largest scales. Though unimaginably large, they remain delicate and thin compared to the distances they span. Galaxies embedded in these walls drift along them, following the subtle currents shaped by gravity and dark matter. Some famous examples, like the Sloan Great Wall or the Hercules Corona Borealis Great Wall, extend farther than any human metaphor can truly capture. They are silent monuments to the universe's earliest motions. Imagine these cosmic walls as gentle, luminous horizons stretching across the night in graceful, nearly infinite sheets. And flowing along these walls are the currents that guide galaxies toward unseen gravitational anchors. Fact 85. The web that holds it all. On the largest scales, the universe resembles an intricate web, a delicate structure where filaments, clusters, and walls connect like threads in an ancient tapestry. This cosmic web formed from tiny fluctuations in the early universe, slowly magnified by gravity into the vast architecture we see today. Galaxies gather along its strands, guided into gentle alignment over billions of years. The web is shaped largely by dark matter, whose quiet pull draws ordinary matter into its patterned embrace. Where the threads cross, galaxies cluster in great knots, and where they thin, space opens into serene voids. It is a design so grand and so subtle that its full scale is almost impossible to imagine. Picture the universe as a softly glowing lacework drifting through darkness, intricate, delicate, and endlessly interconnected. And along this lacework, galaxies move in graceful flows toward regions of deeper gravity. Fact 86. Flows toward gravitational giants. Throughout the cosmos, galaxies drift toward areas of stronger gravity. Massive clusters, dense filaments, and unseen concentrations of dark matter. These motions are known as cosmic flows, and though they unfold over billions of years, they give the universe a sense of gentle directionality. Galaxies are not still. They migrate softly through space, pulled like leaves floating down a quiet river. One such flow guides our entire local group toward a distant region called the Great Attractor, whose gravity subtly pulls hundreds of thousands of galaxies. Though we cannot see the full structure behind this attraction, we feel its influence in the motions of galaxies across vast distances. Imagine galaxies drifting along invisible currents, like tiny boats moving slowly toward a distant shore, guided only by the pull of the tide. And along these currents, some galaxies form elegant, meandering streams of migration. Fact 87. Streams of migrating galaxies. On the scale of superclusters, galaxies often move not as isolated travelers, but as part of long, graceful streams. These streams form when galaxies fall along filaments, bound together by shared motion and the subtle shaping of dark matter. Over immense stretches of time, they glide in the same general direction, like flocks of birds drifting across the sky in slow formation. Though separated by millions of light years, their coordinated motion reveals the underlying structure of the universe. Astronomers map these flows to understand how matter is distributed across cosmic space and how the earliest seeds of structure grew. Imagine looking down from above and seeing galaxies drifting in long, gentle rows, a quiet cosmic migration unfolding across eternity. And as they move, our own galactic neighborhood rests within a broad, gently sloping structure known as the local sheet. Fact 88. The drift of the local sheet. Our Milky Way, along with Andromeda, Triangulum, and dozens of dwarf galaxies, rests within a gently sloping plane of space called the local sheet. This region is like a smooth plateau in the cosmic landscape, where galaxies share similar motions and slowly drift together in quiet harmony. The sheet itself floats at the edge of a vast void, shaped by gravity's subtle influence on both sides. Because the local sheet is relatively flat and coherent, the galaxies within it move with a kind of shared rhythm, as though gliding along the same soft current. This shared motion helps astronomers trace the hidden gravitational contours carved by dark matter and distant structures. Imagine the local sheet as a calm, drifting raft carrying our galactic family across a dark, tranquil sea. And as we sail together, we occasionally approach dense gatherings where galaxies cluster in luminous crowds. Fact 89. The clusters. Where giants gather. Galaxy clusters are the bustling cities of the universe, enormous gatherings where hundreds or even thousands of galaxies reside in close quarters. Held together by deep wells of dark matter and glowing with hot, X-ray bright gas, these clusters are some of the most massive structures in the cosmos. Their galaxies orbit in sweeping arcs, interacting gently and sometimes merging over time. In these crowded environments, galaxy shapes often evolve quickly. Spirals may lose their gas, becoming lenticular or elliptical under the cluster's quiet pressure. Some galaxies plunge through the cluster's hot medium, leaving behind soft trails of stripped gas that fade like dissipating clouds. Yet even here, creation continues. The gas that remains can still form stars, though more slowly than in quieter regions. Imagine a galaxy cluster as a grand metropolis of light, full of softly glowing towers drifting in a shared gravitational dance. And surrounding these crowded cities lies a vast quiet, the space between the stars of stars. Fact 90. The quiet. Between the stars of stars. Between galaxies, in a cluster lies a surprisingly gentle expanse known as the intracluster medium, a thin, hot mist of ionized gas that fills the cluster's interior. Though incredibly diffuse, it carries the faint glow of X-rays and holds the remnants of countless stars that have lived and died within the cluster's embrace. This medium is the silent space between the galaxies, connecting them like a warm, dimly lit atmosphere. Floating through this vast region are stars stripped from their home galaxies, drifting alone yet shining steadily. These intracluster stars form a faint ghostly glow that blankets the cluster, adding a quiet background of starlight to the grand structures within. Imagine this medium as a soft, heated haze stretching between distant lanterns, warm, peaceful, and filled with echoes of forgotten suns. And beyond the boundaries of clusters lie galaxies continuing their slow transformations over cosmic ages. Fact 91. The slow transformation of spirals. Over billions of years, spiral galaxies slowly change their shapes, even if the process is too gradual for any single generation to witness. Their elegant arms may loosen, curl more tightly, or grow softer at the edges as stars shift and gas redistributes. Sometimes interactions with passing galaxies stir their patterns, adding gentle waves or faint distortions that ripple through the disk like quiet sighs. As star formation ebbs and flows within their arms, bright regions fade or blossom anew, giving spirals a dynamic, ever-evolving tapestry. Dust lanes drift, clusters move outward, and the central bulge swells with age. These changes are subtle, guided by the patient hand of gravity and the natural aging of stars. Imagine a spiral galaxy as a flower that opens, reshapes, and slowly folds its petals over eons. Always beautiful, always in motion. And as spirals mature, the pace of starbirth gradually slows, shifting galaxies into quieter phases. Fact 92. The fading of starbirth. As galaxies use up or lose their supplies of cool gas, their ability to form new stars dwindles. This fading isn't abrupt. It feels like a slow dimming of creative energy, as though a once busy workshop is gently closing its doors for the night. Without fresh gas to collapse into new suns, the galaxy's existing stars age, redden, and settle into long, peaceful orbits. Some galaxies reach this stage early due to intense starburst phases or disruptive mergers. Others arrive much later, after calmly building stars for billions of years. The result is a galaxy bathed in warmer tones, golden, amber, and deep red, glowing with the quiet dignity of age. Imagine such a galaxy as a grand library lit by evening lamps, its shelves filled with the stories of long-lived stars. And from this gentle dusk, galaxies eventually enter a serene state where little new light is born. Fact 93. Galaxies growing ever quiet. In the later stages of their evolution, many galaxies become peaceful realms where new star formation nearly ceases. Their gas grows thin, their dust settles, and their bright blue regions fade into memory. What remains is a stable, softly glowing collection of mature stars drifting along well-worn orbits, their lives unfolding slowly in the cosmic dark. These quiet galaxies are not stagnant. They continue to evolve in subtle ways. Stars die and release material that becomes part of the interstellar medium. Stellar remnants cool, dim, and shift positions. Interactions with nearby galaxies may stir their outskirts, but the overall impression is one of deep calm. Imagine such a galaxy as a serene autumn landscape, its colors gentle, its movements unhurried, its light soft and contemplative. And against this quiet backdrop, the universe itself carries on cooling and expanding around them. Fact 94. The gentle cooling of the cosmos. As the universe expands, it grows cooler with every passing age. The background glow left from the Big Bang, once searing and bright, has stretched into a faint, chilled whisper of microwave light. Galaxies drift through this cooling sea, their stars shining into an environment that becomes ever more serene. Over billions of years, the universe's temperature has dropped to just a few degrees above absolute zero. This quiet cooling affects the way galaxies evolve. Gas clouds find it easier to collapse, but also harder to remain warm. Slowly, the cosmos becomes a place of longer shadows and softer energy, where the heat of creation has long since diffused into the infinite dark. Imagine the universe as a vast winter night, crisp and peaceful, its chill spreading gently as time drifts on. And within this cooling expanse, galaxies slowly transition into quieter, dimmer forms. Fact 95. Starless shapes in the far future. Far into the future, When galaxies have spent their fuel and star formation has finally ceased, they will become realms of aging suns and fading light. Their brightest stars will have died, leaving behind white dwarfs, neutron stars, and long-cooled remnants quietly circling through the dark. The once vibrant spiral arms will appear faint and ghost-like, illuminated only by the last echoes of ancient starlight. In time, even the remaining stars will dim and fade as their fuel runs out. Galaxies will grow softer in appearance, their intricate shapes blurring into more diffuse, tranquil forms. They will drift through space like gently dissolving clouds, still beautiful, but profoundly still. Imagine a galaxy in this distant era as a soft silhouette against a dark horizon, peaceful, delicate, holding the memories of countless generations of stars. And long after even those silhouettes fade, what remains will be shaped by something deeper and darker still. Fact 96. Dark matter's last embrace. In the far future, when the stars themselves have dimmed, the structure of galaxies will remain held together by dark matter. The quiet, invisible framework that guided their formation from the beginning. Though ordinary matter may cool, decay, or drift apart, dark matter continues its silent vigil, preserving the galaxy's shape long after its light has vanished. Bound only by gravity, these dark matter halos will endure for unimaginable stretches of time, outlasting the stars and planets they once protected. They will become the final outlines of galaxies, invisible to sight, yet still shaping the motions of any remnants left behind. Imagine this dark matter halo as a faint, eternal hand gently holding the memory of a galaxy long after the last star has slept. And in this deep future, even starlight fades, leaving only the quiet persistence of cosmic memory. Fact 97. Long after the last star shines. When the universe has aged far beyond its brightest eras, a time will come when the final stars burn out. These last suns will be small, steady red dwarfs, gentle embers glowing for trillions of years before fading into quiet darkness. When their light finally ceases, the universe will enter a period lit only by the faintest afterglows, the fading warmth of white dwarfs and the soft radiation of cooling stellar remnants. Yet even in this dim future, motion continues. Planets will still orbit silent cores. Brown dwarfs will drift through the dark like quiet wanderers. Black holes will move on their slow paths, invisible but present. The universe will not end abruptly. It will simply grow softer, quieter, and more delicate with time. Imagine the cosmos as a vast room where the lights have gently dimmed, leaving only the softest hints of warmth. And within this fading glow, galaxies will carry memories written in their ancient light. Fact 98. Galaxies in eternal night. In a universe without new stars, galaxies will become ghost-like structures, defined more by their gravity than their glow. Their remaining stars will be faint and sparse, giving off little light to mark their spiraling shapes. Gas will have long since cooled or been consumed, leaving the galaxies as quiet swirls of stellar remnants drifting in an ever-darkening sea. Over unimaginable spans of time, galactic structures may slowly disperse as gravitational interactions scatter stars into vast, lonely orbits. Yet even as their visible forms dissolve, the galaxy's gravitational influence will linger, shaping the motion of whatever remains. It is a peaceful unraveling, slow, gentle, and unhurried. Imagine a galaxy in eternal night as a whisper of structure barely touching the darkness, like the outline of a dream when waking. And beyond these whispering shapes lies a final truth about the universe, that even in silence, memory endures. Fact 99. Memory, written in starlight. Every galaxy holds a record of its past in the light of its stars. The ages, colors, and compositions of those stars reveal where the galaxy was born, who its neighbors were, and how it changed over time. Long after a galaxy fades from view, the knowledge carried in its starlight lives on in the fabric of the cosmos, shaping the patterns and motions that follow. Even the faintest photon traveling through space is a message from some distant moment, a memory released from a star that may no longer exist. These memories accumulate, forming a quiet archive of the universe's long journey, preserved in light, motion, and gravity. Imagine this memory as a soft imprint left on the night sky, subtle yet enduring, the echo of stories told by stars across billions of years. And as all these memories gather, the universe continues its final, gentle drift into timeless calm. Fact 100. The universe dreams. On even when galaxies fade, when stars cool into silence, and when the cosmos grows dim with age, the universe continues its slow, graceful drift. Space expands with a gentle patience, carrying with it the remnants of every light that ever shone. In this deep future, time stretches quietly, like a soft horizon with no end, holding the echoes of creation in its vast embrace. Though the galaxies grow faint, their imprints remain, in gravity, in motion, in the delicate architecture shaped by billions of years. The universe becomes a dream of itself, subtle and serene, where every past moment lingers like a distant, comforting memory. Imagine the cosmos in this final calm, resting in infinite night, peaceful and complete. And so, the universe dreams on. And as our journey comes to a gentle close, I hope you found a bit of calm among the stars tonight. From the first faint wisps of light to the quiet dreams of galaxies in the far future, thank you for drifting through the cosmos with me, one sleepy fact at a time. If you enjoyed relaxing in this starlit space, don't forget to like the video, subscribe, and comment below what topic you'd love to fall asleep to next. Your suggestions guide future journeys and help other sleepy travelers find their way here too. When you're ready to keep dreaming, tap the end screen to watch the next Sleepy Astronaut video and continue your quiet voyage through the universe. Sweet dreams, and see you among the stars.